Okay, so for 10.2, you're going to use angle measures to find arc measures. So this shouldn't be too terrible, okay? The central angle of a circle is an angle whose vertex is the center of the circle. Okay, so over here, if you have a circle, okay, and then you put the center there, and we usually name circles by like capital letters. So if you draw an angle in here like that, this angle is called a central angle, okay? And if the central angle is less than 180, then the points on the circle that lie in the interior of the angle form what we call a minor arc. The points that are not, so this right here would be a minor arc. So if we had like A, B, that would be AB would be the minor arc. I'm going to put another point out here, okay? If I asked you to go the other way and find ACB, that's going to be way more than 180. So these form a major arc. And the measure of this dotted arc would be 360 minus the minor arc. So let's give these some numbers. So like if this, let's say this was 80 degrees right here, then to find the whole rest of the arc, you would just do 360 minus 80, because we know that a full circle is 360 degrees. Okay, semicircle, the definition of a semicircle is it is an arc with endpoints that are the endpoints of the diameter. So, I mean, I think you probably know what a semicircle is. So if we draw a circle and we draw a diameter here and here, you've got this semicircle going on, which would be 180 degrees, and then you also have this semicircle going on, which would be 180 degrees. So it's really important to pay attention, like here's a diameter. So that immediately tells me like this whole side is 180 and this is 180, okay? So when it asks for D to F to E, they want us, you gotta follow the letters in order, D to F to E. Okay, that is going to be this whole circle, take out the 117. So this is 360, take out the 117. All right. So you can just subtract those. Obviously, you can plug this in your calculator. So this one should have been 243 degrees. Okay. Then they want to know the measure of arc DE. Well, that's easy because the rule for if the vertex is at the very center of the circle, this arc that corresponds to the angle is the exact same measure. And then D to E to F, if you look at that, it goes from one endpoint of a diameter to the other endpoint of a diameter. So that's just 180 degrees. All right, next page. So the measure, this is a lot like angle addition and segment addition. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So it's saying arc ABC is going to equal the measure of arc AB, which is this first little guy here, plus the measure of arc BC. So it's just saying that you can add what you need to add or subtract what you need to subtract. Okay, so let's go down to this next figure. It tells you, you got to pay attention to this right here. These are diameters. So you really want to note that. Okay, that splits the circle in half. This also splits the circle in half. Okay, so they want us to start by finding this arc, PQ. And at first it looks like, okay, well maybe that's not too easy, but here's the center of the circle. So I know that whatever this angle is going to correspond with that arc. Well, if you look across, vertical angles are always congruent. So that arc should be 42 degrees. So this is 42. I kind of like to write these in as I go in case I need them later. T to P to S. So now it wants us to go from T to P all the way around to S. Okay. So what do I know about this whole part from here to there is 180, because that's a semicircle, plus now I know my 42 plus my 64. So 180 plus 42 plus 64. Okay, and you can just line those up or obviously use your calculator So this is going to end up being 286 degrees. And all your minor arcs, like the ones with 2 letters, should be under 180. The ones with 3 should either be exactly 180 if it's a semicircle or bigger than 180. Okay. Now I'm going to go, let's see if I can find, I don't have a lot of different pins down here. Let's see, R to Q to S. So R, where's R? R to Q, look at this, all the way around to S. So basically that's almost the whole circle, but you do not count this 42 right here. So this is 360, take away 42, and that's going to be 318 is this one right here. Okay, P to Q to S, so I'll just kind of, this one's, so you got a semicircle, there's your 180 plus the 42. So 180 plus 42, we have 222 for this answer. And then P to S, so that is going this way, P to S. Okay, you notice here's a diameter, so it's almost 180, but not quite. So it's 180, take away this 42 right here. And we get 138. So just on these types of problems, pay attention to your semicircles, and then obviously note those are 180, and then all the way around the circle is 360, and that'll help. Okay. All right, so for this one, it says find the indicated measure. So I know that this right here is a radius of 9, which means this is also a radius of 9. If they want me to find this segment, I do have a right triangle, so I'm just going to use Pythagorean theorem. C squared is 9 squared plus 9 squared. That's 81 plus 81. So C squared is 162. And then you can square root that. And so remember, there's a few ways you can break this down, but this is obviously going to be square root 81 times square root 2, so it's going to be 9 root 2. Is that answer right there. Okay, and the next one, they want us to find arc D to A to B. Well, first of all, I know from D to A is how much? It goes halfway around the circle. So D to A is 180 plus, I need to figure out this guy right here. Okay, so what do I know? Well, this other half from here around to here is also 180, right? You've got 90 to take out there, and then you know those are congruent. So to get this little part, you do 180 minus 90, which is 90, but then you have 2 that are congruent. So you got to cut that 90 in half, so this would be 45. So you're going to add the 45 here, and that's going to be 225. Okay, last little part here. 2 arcs are going to be congruent if they have the same measure and they're in congruent circles or they're in the same circle. Okay, and so obviously if they're in the same circle, that's going to look like this one. But how do we know if 2 circles are congruent? Just looking over here, the radii have to be equal. Okay, so it says tell whether this arc BC is congruent to DE. I'm going to say yes, they're congruent because same measure in same circle. So that's a good one. Okay, here, this arc would technically be 80 and this arc would be 80, but are these congruent? The answer to this one is no, same measure, but different circles. Those circles are not congruent. Like you can tell, this circle is obviously way smaller than the outside one. Okay, then the last one is this arc FG congruent to arc HJ. Okay, we don't have the same circle, but again, the radii are marked congruent. So no, we know these circles are congruent. So this would be yes, same measure in congruent circles. All right, so that should wrap up 10.2. Let me know if you have questions.